All right, let's look at the homework 2.8, problem number 6. This is a shadow problem. All right, so a man 6 feet tall. So so this guy is 6 feet tall. All right, and walks at the rate of 2 feet per second away from the light. So he's walking this way, 2 feet per second. All right, and let's see, he's 15 feet. Okay, this is 15 feet above the ground. Yep. All right. All right. So when he's 10 feet from the base of the light, so I'm just putting stuff in here. So this is 10 feet, right? So here. At what rate in feet per second is the tip of the shadow, right? So assume that the shadow is going to be over here. So I'm going to draw a shadow. So tip of the shadow is probably right there, right? So that's right? So maybe I'll use a different color. So that's the tip of the shadow. All right. All right, so that's what we're trying to find. So we want to see how fast this guy's going. So this feet per second. All right, so we have that. All right, so we're gonna try to put some variables for changing quantity. All right, so for example, maybe I should draw a picture. It's getting crowded here. So if I draw, let's see. So I'm gonna draw a big triangle. Like that. So that's the street light, and this is the tip of the shadow right there. So this is the big right triangle. All right. So this is 15 feet right here, and we don't know what this is. And yeah, so that's that. All right. And I'm gonna draw a small triangle using using the person. So he's 6 feet tall. And you have that. All right, so as you can see, these are similar triangles. They are basically the same shape but different sizes. So we can do that. So if you guys remember, it's an angle similarity criterion. So you have an angle here is congruent to angle there because we're talking about looking at the same angle. And you have a 90 degrees. So we know that by angle, we know that these are a similar triangle. All right. Then what we want to do is we want to give variable for the quantity that is changing. All right. So for example, all right, the guy is walking away, right? So I'm going to probably call that x. So from here to there, so this is going to be x, right? And since we are also looking at the tip of the shadow too, so I'm going to call the distance between the tip of the shadow to the base of the street light, and since it's shadow, can I call it s, right? So we know that this length right here is s, right? And here, this is just difference between S and X would be the length of the shadow. So this is the length of the shadow, which is S minus X, right? So we have that. All right, so since these are similar triangles, the ratio between corresponding sides, it will be the same for all three pairs. Right, so we're going to start with, for example, if you look at s minus x, right, the corresponding side would be s right here, right, is exactly the same thing as 6 to 15. All right, so we have that equation. All right, so I'm going to work on that a little bit later. What else do we know? We know that since this person is moving away at the rate of 2 feet per second, So the distance x is increasing at that rate. So we know that, let's see, I'm going to write it, maybe write it down. So we know that rate of change of x with respect to time is going to be 2 feet per second. So we have that. And then what we're looking for is at what rate in feet per second the tip of the shadow moving. So what we're looking for is ds over dt. So rate of change of the distance between the tip of the shadow and base of the street light with respect to time. So this is what we are looking for. All right. And at that time, x is 10, right? So it's 10 here. So here x is 10 at that moment. All right, so since we're looking for the derivative, so I'm going to start with this equation and try to take the derivative. All right, but I don't like the fraction, so I'm going to just multiply. All right, I'm going to get rid of s by multiplying both sides by s. All right, so you're going to get s minus x is equal to 6 over 15 s. Right? And then I actually don't even like 15 there. Can I just multiply it by 15? All right, so I'm going to multiply both sides by 15 so that I don't have to see fraction. All right, so you have a 15s minus 15x is equal to 6s. All right, so since I'm working on it, why don't we solve for s? Here, I'm going to solve for s. All right, so I'm going to subtract the 6s. So we're going to have 9s. And I'm going to actually move negative 15x over to the other side by adding 15x. So 9s is equal to 15x. All right, then I'm going to just divide through by 9. All right, so s is equal to 15 over 9x, which can be simplified, right? Because let's see, 5 and 9 are multiple of 3, so divide by 3, 5, divide by 3, 3. So it's actually s is equal to 5/3 x. All right, so we have such a simple equation. S is equal to 5/3 x. All right, since we're interested in the rate of change, so we take the derivative of both sides. So you have a ds over dt is equal to 5/3 is just a constant multiple, and derivative of x is dx over dt, right? So we put that in there, right? But do we know dx over dt? Sure, right? dx over dt is right here. So I'm going to plug that in here. So we get 5/3 times 2. So it's 10/3. Right? So you have a 10/3. All right, so let's type it in. All right, so we have 10/3. All right, let's check the answer. All right, I came back and looks like we got part A correctly at least. All right, let's move on to part B. When he is 10 feet from the base of the light, so it's the same time, at what rate is the length of his shadow changing? All right, so what's the length of his shadow? All right. The length of the shadow is from the person to the tip of the shadow. So it's actually just s minus x, right? Right. So you have s minus x. So I'm going to just, so length of the shadow is s minus x. All right. So then we're looking for the rate of change of that. So we're looking for d s minus x dt, right? But this is just a derivative of s minus x with respect to t. So derivative of s is ds over dt. and minus derivative of x is dx over dt, right? And ds over dt, we just found that to be 10/3. And then dx over dt is 2, right? So common denominator, 2 is same thing as the 6 over 3. So this is going to be 4/3. So you have 4/3 is how fast the length of the shadow is changing. All right, let's type it in. All right, so it's going to be 4/3. All right, let's check the answer. All right, I came back and it looks like we got this one correctly. All right, that's it. I hope that this was clear.